Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem find the highest number. So the problem says that we'll be given an array which will be consisting of n integers in total, and we have to determine the highest element of the array. Now initially the array elements are arranged in the increasing order, but subsequently they might either continue to increase or they might decrease as well until the end of the array. So no element of the array, no adjacent elements of the array are same. So elements of the array are different only because the ith element is not the same as I plus 1th element. Equality will not be there. Okay. So either what might happen is this question previously has been asked in Amazon, by the way. The problem says that either the array can be increasing in order only, then the peak element would be the last element only, correct? Or the other scenario is that suppose the array can be increasing in order and then it can be decreasing, right? So first of all it increases for some time and then after that it starts decreasing, the element starts decreasing. So this can be another scenario. Now in order to find the peak element, or you can say the highest element, one of the very basic approaches is that we can do what? We can simply iterate through the array and then we can find that whichever is the highest element. So basically either the last element will be the highest element if the array is in increasing order only, or if it increases and then decreases. So whenever there is any ith element which is greater than the I minus 1th and I plus 1th element, then I'll say that it is the peak element, correct? Or it is the maximum element, highest element. Now if you apply a linear approach, that is a linear search approach for finding the highest element of the array, so this will take nothing but order of n time. Can we do something better than order of n linear time? Yes, we can do better than that. Like what we can do here is, if suppose that we have got this array, first of all, either the array can be completely increasing, right? This can be the scenario, or the array can increase and then decrease. So instead of linear search, what is better? The better idea would be to use binary search here, right? So whenever we will be at a particular element mid, okay, so we will check if the element previous to the mid, if it is lesser, and the element after the mid index, if it is also lesser, so then my mid will be the highest element or the peak element, then I'll directly return it. But in this particular case, there is one more thing that I need to keep a track of, that suppose that if I am at a particular mid element, so suppose that if I am currently at a mid element, let's say if I'm doing binary search normally, because the array is kind of semi sorted, so we can apply binary search because the search space is monotonic in nature. So if you'll see here, suppose that this is my mid element, okay, and now if this is my mid minus 1th element, okay, so you can see here that if a scenario like this happens where my mid element is what, where my mid element, if it is greater than the mid minus 1th element, okay, so in that case what I can say here is that if the element at the mid index, if it is greater than the mid minus 1th element, but the mid plus 1th element was greater, then this mid is not a peak. But I can say that if this mid element is greater than the mid minus 1th element, so I need to search on the right of this mid. Okay, if I don't find the peak element or the highest element at this mid index, so I'll find the higher element at the search space low is equal to mid plus 1, because I have to search on the right side of this mid, because if this mid is greater than the element on the left, so then I can say that the higher element or the peak element will lie on the right side of the array. So this is how we can apply a binary search. Also, one more thing that I need to keep a track of is, let's say if I am talking about the previous index, so normally we have a habit that we can do what, we can do mid minus 1, but it is not always necessary that we can do mid minus 1, because if the mid is standing at 0, so mid minus 1 would be 0 minus 1, that is minus 1, and minus 1 index is not possible. So whenever we'll be finding the previous, so instead of doing mid minus 1, what we will do is we'll do mid minus 1 and we'll add n to it. Now when we add n, so the overflow is stopped. So when we'll do mid minus 1, then we'll add n and then we do modulo with n. So then you can see that we will get the previous index only. If the previous index exists, then we'll get the previous index. Otherwise, we will get the same mid index. Okay, because if suppose that the mid was 0, then what will happen is, assuming that the mid was there and mid was nothing but 0, then what will happen? This will be n minus 1 modulo with nothing but n. Okay, so when you have got n minus 1 and you do modulo with n, then you'll get 0 only. So if the mid was initially 0, then you'll get 0 only. So previous index, if you're not having a previous index because the mid is 0, then you'll get what? Then you'll get the previous as 0 itself. So it will not overflow. You will not get index out of bound error. So that is why we can do what? In order to find the previous index, we can do mid minus 1 plus n. modulo with n. Okay, and if you have to find the next index, then what you can do for that? For the next index, you can say that the next index will be the current mid index plus 1. Okay, and it might also overflow. So then you will do what? You will do modulo with n, because suppose that if you had the mid value as what? Let's say the mid index was the mid index was n minus 1. If the mid was standing at the last index, then will there exist a next index? No. So then you will do what? You will do n minus 1 plus 1 modulo with nothing but n here. Then what will happen is, if you have got the mid is standing at the last element, so mid minus n minus 1 plus n, so this will be what? N modulo n, so this will be 0. So you can see here that the overflows will be controlled if you follow this particular condition. So let's try and write the code in terms of binary search here and see what we can do here. So firstly, I'll say that my lower range would be nothing but 0. Okay, and my higher range will be what? It will be nothing but, you can say, a dot size here. Then after, like, a dot size minus 1, because the highest element that I can get is nothing but n minus 1. Then after this, what we can do here is, we can say that while the low is less than equal to the high, till that point of time we'll iterate and we'll find the mid index. So the mid index will be nothing but the low plus the high divided by 2. Now once I get the mid, so if the element, suppose if the element at the mid index is greater than the element at the mid minus 1th index, okay, and at the same time the also, since I was talking about previous and next, because we need to keep a track whether the previous and the next index is valid or not, so we'll say that the previous index, that is nothing but mid minus 1 plus n. Why I'm doing plus n? Because if it becomes negative, so I have to make it under control, so I'll do modulo with n here. Okay, so that it remains under the range 0 to n minus 1. So the previous index would be this, and the next index would be what? It would be mid plus 1 modulo with n. Why am I not doing plus n in the next in while calculating the next? Because the next will never become negative. Okay, if it doesn't become negative, so I don't need to add n. But when I'm calculating the previous, so previous might start becoming negative. If it becomes negative, so I'm adding n and then taking this modulus. Okay, so I'll check that if the element at the mid index, okay, if it is greater than the element at the previous index, okay, and at the same time the element at the mid index, okay, if the element at the mid index, if it is greater than the element at the next index, so this means that this particular mid element is the peak element or the highest element. So I'll directly do what? I'll directly return this particular element as a of mid. Otherwise I have to check. So I'll check that, else if what happens is, if the mid element that I have, right, if it is greater than the previous element, so if it is greater than a of previous, then in that case I will say that if the current mid element, if it is greater than the mid minus 1th or the previous element, so I need to say that my peak element would lie on the right side of mid. So I'll say that low is equal to what? Mid plus 1. Otherwise, if that is not so, so in that case my high needs to change, and high will be equal to mid minus 1, because otherwise my peak would lie on the left side of mid. And then at the end, when this is done, so we can simply try to compile this code and check, because the peak will always exist in such kind of an array, because no adjacent elements are same here. Okay, so let me declare the mid here, and now let's try and compile this code and check if it is working fine or not. It should work fine now. Okay, it is getting evaluated currently. So yes, there is another mistake. It says that n was not declared. Okay, so let me quickly declare n here. So n is equal to basically a dot size. I thought that n was given already, but yeah, we have to declare our own n. So let's try and compile it and check if it works without any compilation errors. So there's another error, mid. Okay, so I need to apply equal to sign. Let's compile again after this. So it is working fine on the sample. It is giving the peak element as 6 for the sample input 1 2 3 4 5 6, and then 5 4 3 2 1. Let's submit it. It should get accepted, and the complexity would be same as order of log n, because we are applying binary search. Okay, so it says that the output is not correct. Okay, so I might have made some mistake while calculating, so let's just check this out. So basically the issue might be calculating the mid. So mid will be low plus high minus low divided by 2 here. Okay, so the n value that I have is nothing but a dot size here. Then after that I have my low. Let's check the previous. So previous I have updated as mid minus 1 plus n, and the next also I have updated correctly. Okay, now I think what I can do here is, instead of previous, I can write it as mid minus 1. Okay, so let's try and submit this now and check. It should work fine now after making basic corrections. Okay, So you can see that our code is able to pass all the test cases. Basically what I've done is, if the element at the mid index, if it is greater than the previous element, that is the mid minus 1th, so this means that the peak will lie on the right side of mid. So that is one change that I have made. I hope that you have understood this clearly. Please make sure to comment down understood, and thank you for watching this video, guys.